All right. So what I'm going to do is, let's see. I'm going to just extend this to support nodes, node types inside of these edge references. All right, let's just get to it. All right, let's go to tests, cd jacklang, cd tests fixtures. Go into the directory with edges walk so I can jack run edges walk, make sure that works as expected. Yes, it does. So it prints a dot graph. It prints a dot graph. I'll show you online. Prints a dot graph that looks like this. So this is the graph for this program, and basically, and then basically what I'm testing in this file is that these edge refs go to the right nodes. Damn, I gotta make sure that this doesn't get highlighted as erroneous too in the highlighter, but whatever, it's not a big deal right now. These are all A-type nodes. This is all A-type nodes. I wonder if, I can probably go for a C. I'm trying to think how I can actually test this thing. There's one B-type edge that goes to an A-type node. So from this node, I should be able to try to reach, using any edge, try to reach A-type nodes and get to 3? Yeah, but it would be an even better test if we had some B-type nodes somewhere, so that I could really test this better. I wonder if there's a good program for that. Let me try disconnect. So I don't have to edit these. This is a wild node. I mean, this is a wild ass. Let's try this here. It'll break this test, so I'll just do it for. Nah, it'll break the test. Let's not do it here. I mean, we could just put the simple thing in, and then I can. Yeah. Okay. I know what I'll do. Basically, I'm trying to get a mixture of A's and some non-A type node. There's only A type nodes in this program because it's testing the edges. I'm gonna create an edges walk too, basically. Let's just do that. And then I'm just gonna make it. Let's just call it edge node walk. Okay. Edge node walk.jack. So I'm gonna just mess this up a little bit. I'll just create 2 types of nodes. Node A and node B. That's one change. Then I'll modify this to create. I'll just do a node A and a node B for each. Let's do a node B here. Doesn't really matter. I just want the graph to be different. And then I'll just run this. So let's just run it. What did we call it? Edge node walk. Yep, we have a different graph here. And the different graph looks like this. And I like it. We've got node B, node A, node B. Good. That's good. So what we're going to do is we're going to go to this node in the middle, and then we're going to try to do a node type ref inside of an edge ref that'll hit just say node B's, and expect to see at the end of this journey, expect to see a list like this, but with just node B's in it, because this list has node A's and node B's in it. Okay, so let's go get this bad boy going. All right, I got my test, yo. That's all I need. Then I can TDD this thing. Let's TDD it. Okay. So, all right, this is a test case. So we'll just do this with test language. I'm not going to do full TDD. I'm just going to do my style TDD, which is kind of whatever makes sense TDD. Okay. Okay, it's almost 5. Shit. Okay, let's go. Test language. All right, so we have this one. No, I don't like that one. Let's go. Let's just cut and paste. Which test do we? Let's use this one. Test edge node block. That's good enough. I really should change these. Doesn't matter though. I never use this stuff. I just need the test to pass. That's all I care about. And this is going to be edge node walk, and then this is going to be wrong, which is great. Let me just make a branch for this. Branch right now we're on main. Git check out nodes in edges in edge refs. Okay, cool. So let's put this test in. K test language. Okay, what? Language, not language. Language is incorrect. Okay, so we have that fail, one fail. It's this bad boy. Let's also just print. Come on, chat GPT me. Chat GPT, as my dude says. It's not chat GPTing me here. Well, there we go. A little slow today. If I do that, I get this, and then it tells me it's wrong. Okay, cool. My test is good. Now, I don't actually care. We're going to come back to that later. I just care about what this looks like. Basically, I'm going to try to get another line here that is just using this syntax, which needs to work. And man, I debated this so much, but now I don't know. So the syntax should look like, man, this is because the auto formatter isn't leaving a space, which is so annoying between these two things. I mean, it's fine, it compiles, but I gotta like improve the auto formatting, or maybe I'll just ask Mahendra for some help. Although he's busy. Okay. Let's see. What am I going to do now? Focus. I'll just put it in here. So we need just that. That should work. That won't work. That's actually going to crash pretty hard. But argument of type is not iteratable because it thinks this is, I don't even know why it's an argument of type. We'll get into it, but yeah, it doesn't even run. So what I'm going to do is that the right syntax? I mean, I from a design standpoint, I mean, I can't decide whether we let types of nodes be also in here, because it's not like, it kind of goes against perfect explicit type discipline. I mean, I can also make it like a requirement. You do something like this when you're using a node type. This is more explicit. It's more explicit that it's not specific nodes, it's types of nodes. Technically, this is probably better long term. It's probably better long term to do it like this. Let me just see what this looks like. Yeah, this is fine. That's fine. I think it's better. I think it's more clear that this isn't a specific node object. This is more explicit that you want a node type instead of a node object. I mean, it may look ugly and weird to someone who's new to Jack, but it is Jacktastic. This is a Jacktastic thingy. And it's in the world of these edge refs. And this is actually this is kind of what is it called, a two-way door, right? Because once I go down this door, I can still then decide to support the non-explicit mode. But if I support the non-explicit mode first, it would be a breaking change to then start forcing people to do that. And I don't think this is like supporting this alone is not worse than supporting both, if that makes any sense. So it's like, implement this first because it's okay to keep this forever. It's as okay to have both this explicit mode and non-explicit mode than it is to go non-explicit only, there be a bunch of programs out there in the wild, and then say, nope, we're going explicit now. Like, that's a one-way door change. So I'm going to implement this one first, and then I'll tell people to use the explicit mode. And then if people are like, ooh, I don't really like having an end there, which I don't think anybody would complain about, then I can always say, all right, I'll give you that thing. I'll give you that thing that you wanted. Okay. So before I actually implement this, I'm going to do a quick commit because I do have some changes that are good. Yep, just to test basically. And if I do git status, you'll see I have a new file. So I'm just going to git add. I'm on this branch, git branch. So I'll do a git add dot git commit /m feature node types in edge ref lists. That's what I'll call them, edge ref lists. Git push. Let's git push this bad boy here. And then let's create the handy dandy pull request. I'm going to start to require that pull requests have descriptions, so I need to lead by example and do it myself. What's the description? Oh boy. No types. Adding syntax or allowing not just node objects, but also node types that will function as a filter on the edge ref syntax. Type would then give me all of the nodes connected to here that is of type node type. Boom. All right, that's a sufficient description. It's like the shortest adequate description possible. Okay, so that's gonna be new feature, create pull request, go. Beautiful, got my file, my beautiful changes here. Now we're gonna get in and do the guts of the work. Guts of the work starts with jack.lark. In jack.lark, thank you Lark for brilliant infrastructure done by my homie Erez. He's kind of just becoming my homie now, if I can go so far as to say that. I met him. So let's see. So then we go to, which one is this? This is in the edge ref. Where's the edge ref? Wait. Where is it? What was the name of this grammar production rule? Edge ref. L square. It's this one. Oh yeah, it's this one. Airdraft chain. It's an expression. Oh, I don't have to do anything to the. No, I do. Oh, I do. Yes, yes, yes. I do. If I want to make this explicit only, I'm gonna have to. Actually, it would have been well. Of course, it would have been easier to just do this because the grammar wouldn't have to change. This one requires the grammar to change, and there's two ways I can change it. There's two ways I can change it. Yeah, I could just put the optional filters in here. Like, literally, I could just do this. Node op, comma. Yeah, node op. Node op question mark. I mean, I could just do this. Because you could just have a node op expression. This is nice. This is small. There's some kind of like silly things I could do to change it, which is make this an expression, like an atom, an atomic expression, and then if I did that, then everywhere in the language you can use it, and then essentially, I don't know, it would be kind of weird because I don't like that approach basically for a million reasons. I can get into it, but this is probably the best approach for some kind of minimal. No. This needs to go like this. For some kind of minimal, yeah, it's a minimal change that gets exactly the semantics that I want in, but it's specific semantics that we're making non-orthogonal. So we could do it in an orthogonal way, and it was that way before, with all of the colon, blah, colon, for nodes, edges, and walkers and stuff, classes and yacht, etc. But the issue with that is it's actually redundant, because if they're like, we don't actually have these kinds of things for types of like classes, right? So it would be weird to force to have that everywhere. Anyway, I'm giving a lot of details that is probably, it's too deep into the design decisions. But this is probably the right design decision for edge ref chain. So this is kind of a, it's a very insular kind of semantic that is a good place to, like, rules inside of here, you don't necessarily want to make orthogonal because it's very data spatial and it's okay. So I think this is the right choice. All right. Yeah, like there's no argument that this should be able to be in any expression, because, and just to make this clear, because we already can have types in any expression. This is the only expression that deals specifically with paths through a data spatial graph. And so because we already have a constraint around this kind of expression where it's strictly data spatial, there are rules in here that we want to insulate the rest of the language from. It's kind of like, I don't know, in object-oriented programming, the rules around a constructor, right? Like the constructor has special rules, like it returns none all the time. It's, you know, like you don't want to apply those rules to the whole language. It's okay because the notion of a constructor is strictly an object-oriented concept. And so here, similarly, this is strictly a data spatial concept. So the special rules of this, we want to keep encapsulated in this kind of this kind of grammar rule. Anyway, so those are the design decisions that's relevant. Some of that I talked out loud to reason about, but whatever. So we're going to do it like this instead of changing the nature of expressions throughout the language is basically what I'm saying. Okay. That's a long story for a simple decision. Anyway, so this is going to trickle into a number of other changes, which is, let's go to the parser and see what now we have to do. Let's just cut and paste this since I only have 2 tabs. parse it up UI. Let's do the edge op ref colon, which is, where is it? Edge op chain thingy. So now we have this in there. I think I might have to do this thing because it will probably complain the line's too long. So node op edge ref trailer. Here's something that's interesting. This is the same as this syntax can also be accomplished with this, with a filter comprehension. Maybe I don't do this, right? Because maybe I leave the filter comprehension because we just implemented these type filters. And so you can easily just do node B. Like this actually should work right now. And this is already in the language. Very interesting. This works, right? I'm thinking to myself, does this work? I think this kind of works. Well, this works. This certainly works. That definitely works. I wonder if this works. This doesn't, no wait, what is it? The filter comprehension can only be on an atom trailer. No, so this wouldn't work. This would be a syntax error. Let's see. Let's see. It is a syntax error, right? And it's thinking, yes, it's a syntax error because this is not an expression. That's not an expression, so that's a syntax error. But this isn't a syntax error. This is fine. Right. This is still a syntax error. What the hell? Where? Oh, it's because this is a syntax error. This is line 46. Yeah, that's because we didn't implement this yet. So don't worry about this. Let me comment this out. So the top is works. The problem with the top is, oh wow, it totally works. Like what? like the last change actually covers this desire to articulate this kind of filter in an elegant way. So that's cool. The syntax highlighter is all jacked, but that's going to be fixed when we push the next VS Code extension. So this is cool. Like, do we even need this syntax? That's interesting. I mean, do we still want to have two ways of doing this? The thing I don't like about this is in here, if you wanted to keep going, you could, right? So I could be like, oh, let me go somewhere else in the path, right? And then all of the nodes connected to B nodes, right? To do that here, you would have to do this, which would work. You would have to do this, and maybe this is less readable. Like this works. The graph ends, so it would break here, but with the data we constructed, the graph ends. But like this is how you would have to. No wait, this isn't balanced. Wait, I'm missing. What? Wait, am I tripping? No. This is how you would have to do the node type filters. This is more elegant. So though this works, this is one way you could do it. I think I still want to have this way of doing it. So, I mean, the thing that I'm considering now is, from an implementation standpoint, I can force you to have this, but from an implementation standpoint, what I can do is actually generate. I can generate the AST for this inside of here, right? Because this is just that. It's a filter comprehension on what's at the end of this chain. So what that means is if I detect this node op, I mean, there'll be more complexity here, but I can turn it into a filter comprehension, a very simple filter comprehension, and stick that inside of stick that inside of the chain, and then just have edge-ref trailers be able to support filter comprehensions. That's actually probably the best design from a complexity standpoint. And basically that would impact, check it out. This is what it looks like. So in the absinthe tree, we would have, what is that? Edge ref trailer, not caps. Okay. Here in the chain, we would have expression or filter comprehensions. It would be like this. Or filter compers. Actually, to tell you the truth, putting this here is good. And then it actually can allow and support more filter comprehensions, like a syntax that supports filter comprehensions generally inside of this chain, which is strictly good. Right? Because then you can actually use this inside. So we could just like let this all work, right? So you can actually stick a filter comprehension in here, and which makes sense, right? From a use case standpoint, it makes total sense. You might want to have fully flexible filter comprehensions on the inside. If we do that, do we even need this syntax, right? We could just do expression or filter comprehension on the thing. And then this would be, I kind of like this, right? I like this. I like this a lot. I like supporting this a lot, right? Because then this is a general language feature and construct and idiom that we would then just be reusing instead of creating new syntax for people. Because every single new thing you create is, think of it as one new location in someone's brain that they'll have to learn something specific. So if you only have to learn this generally, and then you can use it in multiple places in the language, that's good design. Instead of having to learn specific bespoke things everywhere. That's generally good if it could be elegant, right? That might seem to contradict what I just said, where we get to have specific rules here. It's a balance. It's a design. You do get to have specific rules there, but if you don't have to have it, then that would be a good thing. So I think I'm actually going to change this up. I'm going to change the approach. I'm going to support this working here. I like this better because it's, yeah. So I'm going to get rid of this line. This was just the line to play with. This is going to be the syntax we support for node types. Now, here's why this is cool. Right? We were talking about explicit. This is always a type, right? Because of this syntax here. So we do get the explicitness of the :n too. So we get a generalized idiom, specific. Oh, it's beautiful. It's fucking beautiful, dudes. So whatever. Okay, so I'm going to support this. Now this breaks currently because of the syntax thing, and that's super easy to fix. And then our absence tree is already upgraded, right? So now we can do expressions or filter comprehensions in the chain. I can change a parser first before I even change the AST to support it. So I'll just change the parsing of the AST to support it, and now valid chain could have filter comps in it. And then there's no type error. Just a very small, tiny change. Dude, simplicity is king. This is awesome. This is the right choice because it's simpler on the implementation standpoint too. So it's just like so the right choice. And what it looks like is not that, but this. So it's edge op ref. Edge op ref. Yes, we have to have that. And then filter comprehensions, parentheses, expression. And then edge off ref, and then filter comper. Yes. So it's like filter comper. That's it. Filter comper or bot in a loop plus sick. No, but this is a question mark, right? Yeah, this is a question mark. Wait. There should have been a question mark on expression. Was there? Let's see. Expression. Oh, there's a plus. Oh, there is a question mark. Ah, ha, ha. So that question mark is also present here. Good. So this is it. So basically the only difference between these two lines is we added a filter comper or expression in the chain. It's very elegant, right? So if I add this, and then I do a jack clean, now I wonder if it's the case that that's all we'd have to implement. It's possible because because this will generate the ASD of the right stuff. We're gonna have to check code gen for edge ref trailer just to make sure that that's okay. Abstract syntax tree is upgraded, and then let's try PyGen ASD. PyGen AST. The cool thing is we also now support, like, you could do it and then have a less than 2, 3. If node type B has fields that you want to filter on, you can filter on those too. This is beautiful AF, dudes. All right, so what am I doing now? Oh yeah, checking edge ref trailer to see. Okay. This is also. You see, the thing about filter compers is it needs.
Are you talking or you're streaming?
Yeah, yeah. I'll be done soon. Yeah.
I'm about to hop on this treadmill.
Okay, that's fine. It's fine. No worries.
Well, I'm gonna exercise a little bit, okay?
Yep. Sounds good. Yep. Sounds good. All right. Filter comper. Let's see. Okay, so we changed that there. Now I gotta actually read and remember this code to validate. This is kind of like the trickiest part. Let's just see what happens when I just run it. It's not gonna just work. It's no way. Yeah. But it dies in a good place, in a healthy spot. I like how it dies. So of course it dies where we want it to, but like right here, right? Because this is the last thing that's printed here. And what we want is for it to say, if it says this, remember this is what it'll say if this is outside, right? If I put this outside, it'll say this. Let's validate. Boom, so that works beautifully. But at runtime, when we execute the logic here, we implemented the syntax, the grammar, the AST update, all that stuff, but not the code gen. So of course we have a runtime error here. And it's because of this piece of code that I've got to read and remember. So this is in the PyGen ASD, PySGGen, and then we do this. We use chomps because I coded this like yesterday. It's in the stream. But I think I was watching Osmond while I was coding it. Anyway. But I can't even remember it now. Jeez. What's that? Oh. If node edges only, for I and node chain, for the last edge equals I, wide length, edge up ref. That's distracting. Pynode, translate edge up ref. Yeah, we need one of these type thingies. So wait, this is and not next I or not is instance next I. Yeah, next I. Then we do this. Else if. Oh yeah. So basically, if you have an edge op ref and then a not edge op ref, that means it's either an expression or now a filter comprehension. We do this, and this probably isn't healthy for filter comprehensions. We actually have to do this or the thing we do in Atom trailers. So this is actually, never mind. I said it was going to be like a pain in the ass. I think I got it. Atom trailer. Boom. We actually have the filter comper logic here. Boom. Let's copy this bad boy. Let's go to edge ref trailer. This is the right design. Ref trailer. Come on now. Okay, cool. Basically, I'm just going to stick this here for now. What? Okay. I'll stick this here for now because this is actually the right elif. Elif, it's what? Next I. or not instance. Wait, if instance and not I or not is instance. Yeah. Not next I. That means we're at the end. If is instance and not. This is modus ponens and just shit that I did. It's always hard to think. Oh wow, we got somebody in the chat. Hey chat, what's up? Okay. If not I or not is instance. So this is the modus ponens thing where if it is a edge and not I, so that means we're at the end we do this. Oh, I see. And then this is else if is instance and next I is edge up ref. If is instance and it's not an instance, actually. Yeah, this is the right place. I'm just getting tripped up for this stuff. Yeah, I'm working on, what am I making today? Right now I'm doing a PR to add this really, really cool language feature that I'm very excited about, which is we have this crazy syntax for referencing edges, referencing paths, right? So I was just showing, let's see. This is super quick. Like I was just showing like, basically I created this test example and you could be at root and you can specify a path from there arbitrarily using edges. So if you want to get to just the B nodes here, which would be like this B node and then this up and then this B node, you can directly access those nodes using these edge reference lists. And I'm adding type filtering on nodes for the edge reference list so that basically this line would return, if you're at root, it would return 2 nodes for the B nodes here. There's B, A, B. It'll just give you the 2 B nodes, right? So I'm just changing the syntax so you can put that inside of your edge ref list. Yeah, there'll be docs on this like at some point. Definitely check it out when you get a chance. So I did the syntax stuff. I did the parser stuff. So updated grammar, change of parsers, updated the AST node in the AST tree, and now I'm working on CodeGen. Oh yeah, there's a GitHub, 100%. And like this PR is actually happening right now. So this is the GitHub. Boom. I'll link you the. I'll stick the link in the chat. I sound like Osman is wild. Anyway, you can check that out and look at this particular branch. Okay, so we've got. So basically, I'm working on CodeGen now, and it turns out that it's actually going to be pretty straightforward because I'm using a very, very nimble little change here. So I'm going to take the. Basically, we're trying to get, it's next I that we're working with. So we can check if it is instance. So this is going to be the right elif. And then we put the first one in an if. None of this is working because the syntax is all jacked. Oh, anytime, dude, anytime. Thanks for joining the chat. Anyway, let's see. We definitely know, well, it's going to be next I because, yeah. If next I and, else if, yeah. This part is a little tricky. Like, this was working before, my brain's not processing like why I need this not next I. I'm sure it makes sense. But this would certainly be true if this code like works. But I think this would be an expression type. I think this would be the change needed. So if it's an expression type, we translate the edge op here using the pi node. There must be a pi node up here, right? This is the original pi node, and then we assign pi node to it. I think we're going to have to assign, yeah, this is pi node will have to equal. So pi node equals that, and so here, what we have is, so this translate this translate edge op ref here ultimately will take in this pi node, which will be, say, root in this case, right? So basically, you know, or like, well, in this particular spot, it would be the next list would take the output of from this prior edge ref into the new edge ref, so you can chain these together. So that's the pi node. But let's see, the func here, pi node equals edge ref pi node. Cur is edge ref. It takes pi node. This cur is actually the args. I gotta go back to see that was left and then right. So this is right. This is left, exactly. So it'll be cur. And then this would be pi node, if I'm not mistaken. Let me see. Because this was, we do a call. This func ends up being, needs to be this guy, which is next I, right? Yeah, this should be next I, because this call, it's turning, basically, this filter comper takes this syntax and turns it into a function, a lambda function, an anonymous function. And then in the code gen, we pass in the output from this ref. So it really ends up being, this is actually a special function call on the data that comes from the edges, the edge output there, to then apply a filter and return post filter. So here we're filtering the nodes, A's and B's, to just give us node B's. So that's actually in the code gen what's happening. So I'm just kind of, so this function is the next I, right? Because the next I is the filter comper return. So it should be this. I don't know why it's not like highlighting, right? But, and then the args is cur, or it's the output of cur. So here in translate edge op ref, if we look at this as an example, this is for a different case. This means we're going to, all right, let's just run this and see if it works. We'll see. We'll see if this like Hail Mary just freaking works. Let's do a jack clean. Before fully understanding the implementation, does it just work? Well, it runs forever. That's interesting. That's definitely not working. I don't know why that happened. Wow, so that's new. Like, I don't usually get like it just running. All right. You see, this is why it's very important to understand what you're coding. All right, so let's see. So next, so here we have here and here. That's the whole implementation, and we're using pi node to translate. So here, see, the key is I think I need to just remember location, the node, the target, and edges only. See, I should use keyword. So this is loc node targ edges only. Okay, so let's go back. So this is node loc. Good. What? Wait, did I get that wrong? I don't understand. Let's see. Translate. No, it's loc and then node. Jeez. Loc, then node. All right. Oh, so loc then node, and so we're translating the edge op ref. The location is the previous. the node equals cur, and cur is our current chomp. Next I is that. So we have cur and next I. So this makes sense. So here we have cur's AST. Let's see how this treats cur. So it takes in, which is the location. Wait. This takes in, location is the pi node. And then cur is the node. So it's node. Which is an edge op ref. Okay. So then the node, let's see what happens to the node. Node is edge dir, filter, con, translate. Oh, I think I know what's going on here. I think I know what's going on here. Basically, the location, this needs to be next I, and then this location needs to be this whole pi node, if I'm not mistaken. This is an edge op ref. Cur. So location equals, I'll show you what I mean. Basically, this needs to look like this. Instead of just sticking a call in there, which is the wrong thing, I should be sticking this whole thing in the location. I think it's like that. I think that's what I need. I think this is the magic. Auto format it. I think this is the magic. Because what I'm going to do is it's similar to this really, except it's not just the set of edges, which would be the location. It's the filtered set of edges, but I'm doing the same operation. So this should work. I think this will work, but before I get too excited, I think this might be messed up, right? Because this is next I. The arguments is cur? Yeah. Wait, no, but that doesn't feel right. That doesn't feel right. Something's wrong. Let's just have it fail. Yeah, it fails. Something feels wrong. It's this cur is wrong. Yeah, this is a very sophisticated piece of code gen right here. So here we're doing a call. Next I is our filter. But we're calling it on the arguments. I think this is supposed to be pi node. Yeah, this has got to be pi node. Is that pi node? Well, pi node is an AST node, so that, yeah. Is that it? I think that's it. Yeah, I think that's it. This is wild. I think that's it. Wow. Oh, I got to do a jack clean. I think this is it. What? What? I don't even know how it's looping forever. That's weird. That's weird. So okay, I'm gonna make some assumptions here. So if all right, what I'm gonna do, I have an idea. What I'm gonna do is I'm gonna get rid of this because I think I'm increasing the complexity a little bit too much, right? Because really, I think what we need to do is we need to first fix pi node and then translate the edge op ref. I think we should just, because pi node all right, so this is back to, I think this is back to where, yes. So this is where we were. So this shouldn't fail because now we're back to where we were before. And we'll get back to this one. Okay, this is good because we're back to where we were before. It's just dying on the last bit because it's handling it like this, and this is wrong. So I think at this stage, I see. Pinode, or is Pinode is always relevant to cur, and then we have the next eye. So this is a look ahead. So basically we're looking ahead at that point, and Pinode is really our nodes. So Pinode is our nodes. Okay, so this is good. So okay, at this stage Pinode is our node. We're looking ahead, and we just want to apply a filter on it. Now, if it is an edge op ref, we translate it with a slightly different thing. If it's not, we translate it with this thing. There's no target. Oh, the target was the filter. Oh yeah, thank you. Thanks for popping in. Yeah. I'll solve this. You can watch it later. I'm close. I can feel it. I can feel it in my bones. This one's tricky though. Okay, let's see. So, okay, Pino's. This one has no target. This one has target. So the difference is it's next eye that's the target of this. Node cur. And then the next eye is the target. Oh. So the target should do this, and then we apply the filter on Pinode. Duh. Okay. Let's bring this back. Let's just do this. I don't know why this is. I think this if statement is causing our forever loop because of this next eye. Let me just do this. Is it an expression? Which it should be. Let's see. I know the solution. I just want to make sure there's not other weirdness when I use that if statement. Okay, so this should be fast. Yeah, there is weirdness with this if statement. See? So the whole time I may have been, I don't know, like, why is this if statement giving us weirdness? It's because it's not a expression. What is next eye? Why would that hang forever? So now we're not even implementing my thing. I'm just trying to understand what the assumptions are here. Let's do it like this. None types. Got it. Oh, it's a filter comper. So it's dying on my actual thing. It's none types most of the time. Okay. Oh yeah, these would be none types. These are none types for the next, because there is no next. If there is no next, what? I don't know. That's tripping me out. Oh wait. Oh, it can be none, and then this is always none. Oh, okay. Yeah. I see. This is a really complex way to do it. But the solution is, because this target is passed in to be a filter here, what we want to do is, I believe we want to execute it as if it's none, and then apply the call to it. So it's basically this, except that we had this part. Let me do this. Let me comment this out. We had this part. Self-sync. We had that part. I'm gonna kill this. Basically, the situation is, although this next eye isn't the right thing, I'll fix it though. I'm gonna implement this in a safe way. Why isn't this? Come on now, just fix. Sometimes my black just dies because it's, I don't know, timing out. Okay, so basically, and then so pi node equals that, and then pi node needs to equal the filter. It's so obvious. It needs to equal the filter on next I. And the args is pi node. Yes. The args is pi node, and we need to do the filter on that. Why is this tripping? Oh, yeah. And this would be if, so if it's, if is instance, if next I and not is instance next I AST dot filter copper. Okay. If next I, it's this if next I and it's not a filter compa, else it's none. That's right. And then this should happen if next I and is instance filter compa. That's what we want. Okay. And then we'll do this part. Like so. And that works. I mean, that type checks out. And I think this is the solution. I'm pretty sure this is the solution. So let's check clean. And then let's FTW. Okay, so we're good. We're good. It works. It works. It's good. It works and it's good. And it checks out. And I'll explain a little bit what just happened there. So yeah, well, the code gen, not surprisingly, for an abstraction like this, is yeah, it's a little tricky. It's a little tricky. But what's happening here is this handles the trail of edges, right? So you know, we go from the root node, we take edge A out, and then we take edge to whatever nodes this resolves to. So this resolves to a set of nodes. So it's the nodes that are connected to root by an edge A type edge. So that's some set of nodes. And then those nodes, that set of nodes, can have edge B type edges. And it's whatever's pointing outward of an edge B type edge and then an edge C type edge. So this is what travels that path to give us all of these nodes, right? So it takes all the, from root, it takes all the edge A type nodes to all of the edge B type nodes and then all of the edge C type nodes, which results into 4 nodes, right? So that's that one. And now we want to filter those 4 nodes. We want to be able to filter nodes as we go. But so basically route to whatever nodes are of a certain type out from the edge. And so we want to filter on node B, right? So we get B, we can switch this to node A, and then we'll just get nodes A's. So that's what we're implementing, right? Just as a recap. And so here we got node A's. Sweet. So so now the code, this is the code gen when we statically analyze, we statically compile this piece, right? So basically I want to augment this code gen to support having filter compers in the chain. And so of what's being generated. And we have all these kind of like little gen functions, right? Like this generates like AST nodes for you know, for like the edge refs applying to the last set of nodes that were then resolved in the previous edge ref. And this is like a while chomp. So it's chomping the pieces of this chain. And while we're chomping, we're gonna be outputting in Pinode, we're gonna be generating more and more sophisticated nodes around nodes around nodes, et cetera, et cetera. Anyway, there's a spot we got to work in filter compers with filter compar's own kind of bespoke behavior, which is filter compars resolves itself into an anonymous function that would essentially apply the if it's a node, and then if the fields are right and all that good stuff. It's actually a lambda function that filter compar resolves to, and then you can think of it as the higher node in the AST is responsible for using that lambda function in the way that it makes sense. In this case, it's calling that lambda function on the results we have so far. So I'll just show you the correct solution is after we do our edge ref process, if the next I is this filter function, we're going to call, what's going on here? We're going to call this next I lambda, which is a filter compar. We're going to call that filter compar on the result so far, right? So this is the result that it keeps updating itself as we iterate through the chain. Very complicated little loop there, but this is actually the solution. There's very few places in the code that would have complicated code gen. It's really like basically it's some of the data spatial stuff is where the complicated code gen comes. It's either a complicated code gen or I do a call out into these libraries, right? Not these libraries, but there's a library that implements a lot of Jack semantics in Python, so I can code gen calls out into that library that's written into the Jack Lang engine. Anyway, so that works. So let's finish this up, and then I'll get out of here. So we have our new test case, edge node walk. And so we've got that. Let's just go to the actual test, which is in test language. Just getting reoriented here. It's right here. This test should fail. Well, actually, it would pass here. But let's not do that. Let's make it fail, right? Because we should get B's, node B's. So now if we do Jack, PyTest, okay. What was it called? Test language. Yep. So we have one fail on test language. It's this guy. It can't find this thing in the output. The output has everything else, but really we just want node B 2, node B 42s. So this may pass. Let's see. Yeah, that passes. We don't need to print this to the screen. So now we have a test that this syntax works. So we did a lot in this little session, right? Like we went through some design decision as to what we'll implement now. This is actually relatively elegant. I mean, the syntax might look weird, but once you understand what a filter comprehension is, it makes sense. You can do your filter comprehensions on this. It's very natural and it's orthogonal with the rest of the language. And then we also implemented it. And then we did that's some of the most, I think that's probably the trickiest code gen function. Nah, that's not true. There's one or two other code gen functions that are also tricky. But there's not many. There's 3 or 4 production rules that create these kinds of complex code gen situations. No, it's not too bad though. All right, anyway. Cool, so we have the test in. Now the test looks clean AF. I'm gonna do a full test while studying the diff. So if I go here, Jack Lang, I'm gonna do git diff. I usually do this before I merge to main. So I'm actually doing a code review of my own code to make sure there's no printfs and stupid crap in there. So here's the abstract syntax tree change. Here's the language grammar change. It's very beautiful because it's good for the language orthogonality. It's better for the language orthogonality than what I originally planned to implement. So that's good. Edge ref chain. This is That's the parser, the AST stuff, whatever. This is code gen. No weird printfs anywhere. We've got our new test case. We got rid of that printout to the screen. We updated the assert. All the tests pass. Git add dot git commit dash m feat feature done. I'll do lang. I'm really gonna have to get more disciplined with these commits, but let's just do that. Let's get push, and we're gonna merge this bad boy because I code reviewed it. Push. Good. And then let's see. Let's see what we got going on. Let's look at our pull requests. Here we go. This is it. Let's just do one more quick check. Nothing ugly is sneaking in. Our test case. Boom. Beautiful. All of that work for just like what? This is always good though. Simplicity is king. Like if you can implement a new feature in 2 lines of codes, that's better than 50 lines of code, right? Yeah, the kids are getting rowdy. I probably gotta go hang, play some games or whatnot. Let's see. Filter comper, beautiful, good. Ooh, cancel. Chain bop. This one, this one. All right, let's review changes. Well, oops. I don't know what that was. I'll just have to merge it because you can't review your own changes. Merge. Boom. All right, good. So that's done. So basically, in a way, that's one of the final things that I really, really like must do's, right? Off of like, I do have a little cheat sheet here of the things that I wanted to do, my wish list stuff. Let me just check it real quick. This is based on my chat with Ping and his experience, like hacking some Mica buddy goodness. Let's see. We still got to do the revisit logic stuff and exposing the path, but like those are some like we got to still be thoughtful about those design decisions. These are the like obvious like improvements, and we have done all of it. Yeah. Yep. All right, cool. I'm gonna connect with him and like tell him about this stuff. I gotta work on documentation, guys. That'll be fun to watch me work on documentation, I guess. All one person that's that's checking out my streams. All right. Okay. Cool. All right. Anyway, all right. I'm gonna go. Good stuff. Thank you, guys. Rock on. Later.